correct?
Yes, sir.
Yes, sir.
Now, is there any doubt or any query queue using array implementation? Is there any doubt or anything is required? Otherwise, shall we go with the queue implementation using linked list?
No doubts.
Yeah. Then we'll continue yesterday's topic. Is this my screen is visible now?
Yes, sir.
Yeah. Now you know the queue data structure again. Just I am recalling the things. Queue data structure. Here always when we are going to use queue data structure, you must know the generally how we are going to form a queue. Here those rules we can apply. Here when you want to implement a queue data structure insertion and deletion is takes different ends. Your insertion from front side, which is called as front. This operation is called as insertion must be insert from end. Okay, insertion must be insert from end, which is called as rear. This operation is called as enqueue. The deletion always from front side of the queue, which is the name, the pointer itself, it is called front, and this operation is called as Dequeue. Means the insertion is takes one end and deletion is takes another end. So that's why it follows first out order or last out order principle. Here, if we are going to observe again a queue, here we have two ends, means two pointers are required to notify that insertion and deletion. So that's why here it is going to follow first in first out order and last in last out order. And especially already I told you it is a linear data structure. Now we are discussing about linear data. Complete first unit all are linear data structures. This linear data structure is nothing but it is going to access the elements in a linear fashion, nothing but sequential fashion. That's why here we have to understand this is it follows linear data structure. Here coming to QADT implementation, there is two ways we can implement. One is using array and one is the using linked list. In the last class, already we discussed about how to implement a queue using array. Here you know array is a static nature, array is having static nature so that before using array for any situation, for any kinds of implementation, we have to define the size of the particular array. Once we are giving the size to array, we cannot change the size. Means we cannot reduce the size, we cannot increase the size when the elements are going to add more. So that is the big problem already I told you. And along with that, here always array is going to take contiguous memory blocks. Sometimes if it is not possible, then our operating system cannot be allot memory for our array. Here this is also one more problem that we can look at time of industry implementation. For our academics only we are implementing very small programs. Maybe you never get such type of problem. But industry it will be happen. That's why things are maybe you can understand. So now for this, initially, the queue is empty. That's why the front and rear pointers it is pointing to -1. Sure, when we are going to declare any array. Sure, when we are now here we are declaring queue. That's why the pointers are front and rear. Already you know why two pointers is required. So one pointer is used to inserting the element which is called as rear. Always we are inserting element from end of the queue. That's why the rear pointer we are using. And another pointer is used for pointing to deleting of element. Nothing but from queue, we are going to delete from front side. That's why front pointer is pointing to the beginning of the or starting of the first element of the queue. So this is the way we can discuss it yesterday. For this, we know the menu bar, how to design, this is common story. And for when we are going to insert an element, means in queue, first of all, we have to check that particular possibility is there or not. Because if the queue is full, because it is using array implementation, that's why we have to check. Here, the queue is full. If the queue is full means the array size. Okay, all elements are inserted. Maybe the array size is four elements already inserted. When you know the elements are inserted, only one case, that the pointer, the rear pointer points to last element. How we know the last element? Array indexing is starts from 0 to n minus 1. So that's why here I have taken max. That's why the rear equal to max minus 1. So whatever the case, front wherever it is immaterial to us, because in queue we are going to insert elements from rear only. So that's what we have to check, only rear. So don't think about the front. So that's why here the rear is in the position of max minus 1. We cannot insert because the queue is full. Because we have to insert through the rear of the queue only. Here now, if it is not full, means rear never points to max minus 1. The rear, wherever it is immaterial. So if it is not points to max minus 1, there is a space. Then we can insert one element. That's why we move to the else part. Here now again here we have to check one more condition. Here because here if the front and rear points to minus 1 means the queue is empty. If the queue is empty, even front also points to minus 1 and even our rear also points to minus 1. So we have to insert element from rear only, but if it is empty, here we have to check this empty or not also. So this is the one thing you have to remember. So that's why here if front equal to minus 1, automatically the rear equal to minus 1. Yes, it is 100% true condition. Yes or no? Yes or no? If front equal to minus 1, the rear equal to minus 1 or not? Yes or no? No response. Is it audible?
Yes, sir.
Yeah, if front equal to minus 1, the rear equal to minus 1 or not? Hello? Front equal to minus 1, directly rear equal to minus 1 or not?
Yes, sir.
Yeah, that's why yeah, when we want to insert an element, you have to move your front to next location. So that is when the queue is empty. Okay, then you can insert. Otherwise, it moves to the else part. Then we are going to increment rear by 1 and we are going to insert the new element in the particular position. Now, for deleting here, only two mechanisms we have to verify. If the queue is empty, we cannot delete any element. When the queue is empty, tell me anyone. When the queue is empty, when the queue is empty,
If rent is equals to minus 1.
minus 1, very good. If front equal minus 1, queue is empty, we cannot delete any element. Here, that's why we can tell the queue is empty. We'll go to the else part. Now, else means, okay, element is there. If the element is there, just you have to move your front plus plus, and you must check the front never moves after the rear. So that is very important. When front moves after the rear, compulsory the queue is empty. You know, if only one element is there, what happened? Front and rear is pointing to that single element. There once deleting means front has to move to next position. When it is moving means indexing is greater. Front indexing is greater to rear index. When that such case will come, then we are going to assign front rear equal to minus 1 because queue is empty. Understand this point? Understand everyone? The same thing I am repeating yesterday's things. Understood?
Yes, sir.
Now the last one is the display. So display, when we are going to display, when the queue is not empty, we can display. That's why you have to take the first queue is empty or not. Same condition, front equal to minus 1. We have to check if it is not minus 1, Then it moves to L spot. Then we have to give one temporary variable I. We are assigning front to I. Then we are going to traverse from front to end. Here every indexing we have to print that element until it reaches to rare. So this is what exactly yesterday we discussed. Yes or no? Is it clear now? Is it clear? Is it clear? Hello? Is it clear? Are you
Yes, sir.
following? Yeah. Please respond. Otherwise, how can I understand? Okay. After this class, I will show the execution of stack implementation as well as queue implementation also. After this class, maybe today we are going to finish the first unit. That's why please carefully understand. Now, queue today we are going to understand queue using linked list. Queue using linked list. Now tell me here, what are the advantages using linked list? Tell me, like stack implementation using the linked list. Now we are doing queue implementation using linked list. Tell me advantages. Sorry. Hello.
We can add or delete elements from the middle also.
No, yaar. Now how we are going to add delete element middle? What is the queue structure? Hello. We are implementing queue. We are not implementing linked list here. We are implementing queue. What are the queue structure? From where we are going to delete, from where we have to insert elements.
From rare we insert and from front we delete.
Then how we are going to tell middle? Don't
Yes, sir.
tell. We are applying queue properties on linked list. Okay, that's what. When we are using this, then what are the advantages compared to the array implementation of queue? So that is what I am asking. What is the advantage? Tell me, anyone? Anyone? Already we observed these advantages in stack implementation also. When you implement queue or stack using array, it is a static nature. The size of the queue or stack is fixed. Yes or no? Yes or no? Hello?
Yes, sir.
Yeah, array size is 4, the stack size is 4. Queue size is also 4. Here we never increase the number of elements you want to insert. Even you cannot only we are inserted 2 elements, but remaining 2 spaces are going to waste. Yes or no?
Yes, sir.
Then using array, there is a problem for overflow error in the both the cases in stack implementation, queue implementation. Yes or no? Yes or no? We can get a overflow error or not using array. What is overflow? Hello? No one is responding means no one is following. Shall I end the class? Second year students, A section students, shall I close the class? What are doing? I am asking you. I am not getting any response from your side. Then I will close. What is the need? I will assign one more faculty. What is this? It is not good thing. Otherwise, you can read yourself. Hello? Are you there?
Yes, sir.
Yeah, my question is very clear. Then respond. If you don't know, I will tell again. What is the problem in that? What is overflow error?
When we try to insert when the queue is full, again we try to insert it. It is known as overflow.
Yes. Here, that problem will come only when we are using array to implement the queue. Yes or no? Yes or no? Here, that's why
Yes,
Yes.
queues
sir.
are going to
Yes,
avoid
sir.
that error because we can insert any number of elements but because it is a dynamic memory allocation. Here I am telling this continuously from single linked list, double linked list, circle linked list, stack and queue. Same point I am repeating. This is the fifth time we are discussing about dynamic memory allocation. Are you clear? Now,
Yes, sir.
yeah. Now there is no
Yes,
fixed
sir.
amount of memory. Cut చేసే phone. So that so that their queue implementation using linker list is the best. Whenever we are go with dynamic memory implementation, maybe writing of the program, maybe it will take more number of lines, but once we are going to implement the accessing, the managing of that particular data structure is more convenient and more faster. Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Sir, now just we are
Yes,
going
sir.
to understand how this particular queue implementation using linked list. Just I will show one diagram, then you can understand based on that. Now, when you wanted to implement a queue data structure using linked list, you must know the node structure. Here, what is the node structure of single linked list? Tell me, what is the node structure of single linked list?
Data,
ADT.
data, and the link of the next one.
Node is divided into two parts. One part is for storing the actual data. Another part is for storing
Address
the address of next
address of next.
following node. Very good, very good, very good. Yeah, this is what I am expecting from you. Respond. That is happy. Okay. That's why when we are going to observe the queue, here now the nodes are connected sequentially. Just I am drawing. Now every node connected to its next following node. The node which is not connected to any node means which is going to connect to null. It is called what? Rare. Now one more pointer is there, that is a starting of the node which is passed to front. Now I want to insert one more element. This is a queue. Now I want to insert one more element. Which element you want to insert? For example, I created a new node, that is NN. Here, single linked list. That's why very easily you can understand whatever I am telling. And queue data structure. From where you want to insert this new node? Tell me, anyone? From where you want to insert?
From
From
rare.
rare side of the queue. Very good. Means rare and NN. Then if you want to
From
insert,
rare.
then what is the logic? What is the logic? Tell me. Hello. What is the logic? What is the condition we have to write? How to connect? This new node you want rare next equal to NN. Very good. Here instead of this, rare next equal to
Rare
NN.
next.
Then after that, which one is the rare now? Which one is the rare? NN is the rare. Then we have to make it rare equal to NN. This is what when you want to insert. Sir, when you want to delete, which element you have to delete always? Which element you front? So now, if you wanted to delete front, then you have to
Front.
take one temporary variable to assign to the front. Front moves to its next. Same story. This code already you have written. Move to front and free of the T. Then it will deleted. So this is the way we are going to delete. Understand? I will show you the code. Don't worry. Understand, everyone? Means your same single linked list code only. Just we have to apply queue operations, queue logic here, queue principles here. Are you clear?
Yes, sir.
Yeah. Now coming to the code. So generally, already I told you, node data structure is divided into how many parts? So that's why you have to define the node, right? In array, it is a predefined data structure, just you have to define the size. But here, node is a user-defined data structure. Single linked list is a user-defined data structure. That's what you have to show, you have to prepare the ADT. Then tell me, node is divided into how many parts? How many parts? Two parts. That is what? Data part and address part, right? This is for data. So already you know all these things. Again, I am explaining. Clear? Clear?
Yes, sir.
Yes, sir.
In this queue, we need two pointers. One is pointing to the rear, another one pointing to the front. So that's why I have taken two pointers. Initially, the queue is empty. That's why front equal to null, rear equal to null. Is it fine?
Yes,
Is it
sir.
fine? Yeah, these are the methods I am going to use: insertion, deletion, and display. So for that, so this is a menu. This menu also same copy and paste. Are you clear?
Yes, sir.
Yeah. Now coming to the first operation, insertion, that is called Enqueue. Enqueue. Technically, we can call Enqueue. You can use any name, but Enqueue is a technical name. Like push and pop operation in your stack. Here we have to use Enqueue and Dequeue for queue. Okay, now Enqueue. Here, when we are going to insert a node, then we have to prepare a new node and assign the data. Yes or no?
Yes, sir.
Right. Now, here I am preparing new node. Here, when I call new node, what happened? Your node structure will come. This is what new. The name I have taken here, new node. Okay, you can take NN also, not a problem. Don't confuse. Okay, the names, variable names, you can use anything. Okay, new node is there. Right. Now we have to prepare memory locations dynamically. Yes or no? We have to arrange memory dynamically. Yes or no? For that, we have to use malloc function. Yes or no?
Yes, sir.
Yes,
The
sir.
same line we have to use. Now, here, now we are going to ask data. For what? Here, this is the data part. We have to ask data. New node data equal to value. So this function is going to send the data. Are you clear? Whenever you call this function, where is the function? Here, the first case one is insert. Here we are calling insert of value. Before this, we are reading the value. For example, we are reading 7. Here 7 will come. Are you clear now? This is a 7. Are you clear?
Yes, sir.
Yeah. Now 7 is there. Now new node next equal to null. This is the null. New node next equal to null. Your node is ready. My new node is ready. Then you can insert. Here from where you have to insert a new node in a queue? Tell me. From where you have to insert new node in a queue?
From there, sir.
From rear. Yes. Here, in which case we cannot insert a new node? In which case we cannot insert a new node? Is there any problem like that? Using linked list? Hello? In which case we cannot insert a new node?
If run is equals to null.
No, no, don't look this code, please. My question is different. Here, this code is different. My question is, when we cannot insert new node into a queue. When
We will not
can,
have such errors in this because
Sir, actually, we cannot insert a new node in a queue is full. But here there is no chance of queue is full because we are using dynamic memory allocation. Yes or no?
yes, sir.
That's why that condition won't work. Now here we have to look at two conditions. One is queue is empty, another one is the queue is not empty. Are you clear? Are you clear? Are you clear?
Yes, sir.
When queue is empty, how to know? How to know the queue is empty? How to know
Front
queue is
equal
empty?
to null.
Front equal to null. Sometimes you can take rear also equal to null. Both condition will work. Yes or no? Because when queue is empty, front equal to
Yes,
null
sir.
and rear equal to null. No element is there in the queue. So that's why I have taken only one condition. Otherwise, you can take rear equal to null also. When both are empty, both are null, then if the queue is empty, what should we do? Queue is empty. Now what happened? This node I want to insert. Then what happened? Tell me. So this is a queue, yeah. Empty. No element is there. What should we do? No person is there in the queue when I am going to collect the tickets. Then who is the first person?
Make the new node as the front and rear.
Myself is the first person. Now this new node as we are going to make it as a front as well as rear. Yes or no? Yes or no?
Yes, sir.
That's why here front equal to and rear equal to new node. Are you clear?
Yes, sir.
Sir, no person is there in the queue. Just I went for my reservation. Then I entered into that queue. Here I am the first and I am the last. Yes or no?
Yes, sir.
In the same way, here if there is no node in a queue is empty, then whatever the new node I am inserting, that is the first node and last node. Okay, this is the case. Else means queue is not empty. If queue is not empty means, here I will draw something here. Here Q is having one element, two element, it is immaterial to us. Just I am taking two elements. Any number of elements, it is not a problem. This is front and this is rear. 4, 5. Right? It is pointing to null. Correct? Always rear, next pointer is null. Correct?
Yes, sir.
Right. Right. Now in this case, here it is going to check if front equal to null is here. In this case, front equal to null.
No, sir.
No, sir.
No.
No.
No. Then my queue is not empty. My queue is not empty. Maybe one element is there, two elements is there, n elements is there. It is not an immaterial. Here now my queue is not empty. Then we are going to insert your new node from where you have to insert your new node.
Yes, sir.
From rare.
Sorry.
From rear.
From rare, we have to insert the new.
From where we have to insert. Now you know the rare. Now you know the new node. Tell me how to write the logic.
Rare next points to the new.
Rare next equal to here. Rare next equal to new node. Understand?
Yes, sir.
Now which one is the rare now?
New node.
New node is the rare. That's why you have to write R equal to new node. Understand? Always the last node is a rare in the queue. Correct? So this is what rare equal new node. Understand everyone? Yes, very good. Now comes to delete. Deleting the element from queue. When we cannot delete element from queue,
If queue is empty, we can't delete.
if queue is empty, we cannot delete the element from the queue. Tell me what is the condition. You can understand the queue is empty. Tell me the condition.
Rear equal to null or
Yeah,
front
yes,
equal
yes,
to
very
null.
good. Rear equal null or front equal null. But I am taking the front only. Otherwise, you can take rear also. Now, when it is null, we cannot delete any element. It is which condition? Which error it is? What type of error it is?
Underflow.
Underflow.
Yeah, underflow error is everywhere. Maybe if you implement using array, if you implement using linked list also, here we are having a underflow error. Sometimes placement people, some people will ask, what is the common error for all types of implementation? Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Yeah. Now, now we are going to check. No, my queue is not empty. My queue is not empty. My queue is having some elements. Understand? Hello?
Yes, sir.
Now just I am taking my queue contains two elements. Now this is front and this is rear. We can do any number of elements. Just I am taking only two elements. Please. Right. Now tell me from where we have to. What is the condition? If front equal to equal null. Front equal to equal null, no?
No, sir.
No.
No,
Then
sir.
it moves to the else part. Now which element we have to delete? From where we have to delete from queue?
Front.
Front, sir.
From front. Means after deletion, this front is moved to its next node. Yes or no?
Yes, sir.
Yeah. After moving this node, it moves to the next node. Here, next node, if it is moving, means after moving next node, we cannot get this node. That's why we have to take one more temporary variable for freeing up this particular memory block. That's why we have to take one temporary variable, that is temp. You know, same logic we used in our previous single linked list mechanism. Correct? Yes or no? Yes or no?
Sir.
Next we must move front equal to front next. Right now this is the front now. Now next is what? We are going to free the temp. Yes, we are going to free the temp. Now this is the free, this is the rear. Are you clear? Are you clear?
Yes, sir.
Again,
Yes, sir.
I want to delete. Sir, if front equal to equal null now,
Yes, sir.
front equal to null now,
No, sir.
then it moves to the else part. Else part. Now again, I declared one temporary variable for this front, right? Now front is moved to front next. Front is moved to front next. Yes or no? Yes or no?
Yes, sir.
Now free of temp. Now I am freeing of temp, removing
Yes,
of
sir.
this. When I am removing of this, the rear also points to null. Memory we are deleting, right? Rear is pointing to null. Then again I wanted to delete. Means I am telling if the link queue contains only one element also, same condition I am using. Okay. Now if front equal to equal null or not?
Yes,
Yes,
sir.
my queue is empty. Now it is working for all the cases. Yes or no?
Yes,
Yeah.
sir.
So this is for delete operation. The last operation is display. Here display means we are going to display the elements in a queue from front to rear. Yes or no? The elements are queue is front to rear only. Yes or no?
Yes, sir.
It's a sequential data. Here when we cannot display the elements? When we cannot display the elements.
If the queue is empty.
Yes, very good. If the queue is empty, then what is the condition? To check the queue is empty.
Front is equals to null, then queue is empty.
Yes, very good. Front equal to null, then queue is empty. Or rear equal to null, the queue is empty. Very good. Now just I am drawing my queue. This is front and this is rear. Now tell me, now my queue is like that. Now if front equal to null now,
No, sir.
No.
if it is no, moves to the else part. Now here, now I have to print the elements of queue in a sequential fashion, you know, from front to rear. Here now I have to traverse from front to rear. That is what I don't want to use front only to traversing of rear until we have to find the rear. That's why I need one temporary variable to traverse in a queue from front to rear. So that's why I have taken temp here. Right. Now we have to traverse until what? When that temp next equals null. Means you know very well, always rear next is null. Means you have to move until rear. That is what I have taken. Temp next is not equal to null. Are you clear this condition?
Yes, sir.
Right. Now temp next is null now.
No, sir.
There is no following block as to execute. What is that? Print temp data. What is the temp data?
3.
3.
3.
Very good. After that, here we have to move temp equal to temp next. Now this is a temp. So then later, next iteration. So now temp next is null now. Temp next is null now.
No.
If it is no, what should we do? If it is no, what should we do?
Print the temp value.
Print the temp data value. Then true. Then temp moves to its next. Then what should we do? Again, temp next is null or not? Temp next is null or not?
Yes, sir.
Yes.
Then out of the loop. Now we are at this position, but we are not printed this. That's why I have taken one more printf statement, temp data, print temp data. What is that? 1. Are you clear my code?
Yes, sir.
Yeah. So this is the display of the elements in a queue in a sequential fashion. Everyone is understood using linked list to implement the queue?
Yes, sir.
Okay. Shall I show execution of the stack using array, stack using linked list, queue using array, queue using linked list programs?
Yes,
Shall I
sir.
show?
Yes,
Yeah. Okay. Please, I will show that execution. Even I will share after this class. Please follow and execute it. Okay, and practice it. If any doubts are there, please revert me back. Your next class or not, we will discuss second unit. If anything is there, you please inform in the next class. We can discuss any doubts or any clarifications. Now coming to the first thing, already we discussed all these things. Each and every instruction. If anything is there, you must ask. Here, stack using array implementation. You know, stack implementation, you know, first in, last out order, last in, first out order, it follows. Insertion, push and pop operation will perform only one end, it is called as top. Only one pointer is required, that's a top equal to -1. Here we are implementing using array, that's why you have to define the size of the stack. That's right. Means array. Means stack of max. Means the stack size is 10 only. If we are inserting more than 10, it will be show overflow error. Now these are the operations. This is menu. You know how to write. You know very well. Already we done so many times. Now push operation. Here we are going to push the element. When we cannot push, the stack is full. That's what the top equal to max minus 1. So otherwise, we can increment the top and we can insert the element. Here, this is the story. Pop, when we cannot pop, top equal minus 1, we cannot pop the element. Otherwise, we can pop. That is what simple top equal top minus 1. And then we are going to display the elements. We have to display when we cannot display. When stack is empty, we cannot display. Otherwise, we can display. Always we can display the elements from top to bottom in a stack. So that is what we are going to take one temporary variable I equal to top. Then we have to do it and decrement it because we are using array. Okay. Clear this? Shall I execute it? Shall
Yes,
I?
sir.
Yeah. Now my menu, it will goes to first of all main method. You know very well C programming always C compiler always checks the main method where it is main method. So through main only we can do all the things. So it's the functional programming, right? That's why. Here now in main method it is showing menu bar. It is push, pop, display, exit. Whatever the option. Here one for push, two for pop, three for display, four for exit. You know very well what is this. Right. Now, for example, I want to display elements. I am choosing three. Here now, initially the stack is empty. That's why, you know, the top equal to minus 1, we are assigned using array, right? That's what. Even I want to pop it, even though it is going to tell stack is empty. Yes or no? Because initially the stack is empty. We are not inserted any element. Yes or no?
Yes, sir.
Yeah. Now only we have only one option. One is push, another one is the exit. Okay. Now go with the push. So when we are asking to push element, compulsory it is going to ask which element you want to push. For example, I entered 23. Yes. Now insertion is success. Now I want to display. The 23 is there. Again, I want to insert. Here 34 I am inserting. Now where it is going to insert? Again, it is going to insert only one end, right? That is top. Yes or no? Yes or no? Yes or no? Hello? Are you following?
Yes, sir.
Yeah. Here 34. Here means the top of the, what is the top of the element? The element which is you are inserted last, that is the top of the element. The element which is inserted last, we can pop that element first. Since it is the last. Understand? Understand? Hello?
Yes, sir.
Now if we want to pop, which element is going to pop now? Tell me. Which element it is going to pop?
34.
Because you know top of the element it is going to pop. Yeah, because stack is follows first in last out order or last first out order. Now 34 is deleted. I will check what is the structure now. Yes, 23 is still there. Again, if you want to pop, then 23 is deleted. Now I want to display. Now it will show stack is empty. Are you clear this?
Yes,
Are you
sir.
clear this? Yeah. Now just I am exiting because all conditions I verified. Yes. So this is using array. Now I will go with using linked list. Using linked list. You know here we are using linked list. Here that's why node is divided into two parts. One part is for data, one part is for storing the address of list. Now here always initially the stack is empty. That's why top equal to null. Okay. Now same menu and operations. Here when you want to push, here we cannot check the stack is full or not because here we are using dynamic memory allocation. So that's why we can insert a number of elements. It is not a static nature, it is a dynamic nature. So that's why if we are going to check only two conditions, one is stack is empty or not. If the stack is empty, then we can make it that new node as a top of the element. Otherwise, we are going to insert a new node as a top. and the top is moved to the new node, then we will do it. Here now pop. Here we have to check two conditions. The stack is empty or not. If the stack is empty, we cannot delete any element because it is underflow. Otherwise, we can pop the top of the element. Means top is moved to its next node. Here now display, from top to bottom, we are going to display. Only one case we cannot display the element when the stack is empty. Otherwise, we can display the elements where top is moved to its next, its next, its next. Then instead of top, we have to take the temporary variable when you are going to traverse. Are you clear? The same thing. Whatever I explained, each and every line in the theory, same thing, it is there in the program. There is no different. Are you clear? Are you clear this?
Yes, sir.
Are you clear this?
Yes.
Yeah. Just I'm executing. Here end user doesn't understand. Only it will be show same. Using array, using linked list, they know only same. But only the problem is we know as a developer, as a programmer, that is a static implementation, this is a dynamic implementation. But end user is having same options. Three, if we enter three, stack is empty. If we want to pop, stack is empty. Okay, that's why we have to insert. Here I am inserting 23. Yes, if you want to display 23 is there. Again, I want to insert 34. Then I want to display, yes. Now 34 is the top. Here, when I want to pop, I am pressing 2. Then top of the stack is going to delete it. That is 34. I will show with the help of 3 option. Yes. Now 23 only there. Again, I want to pop. Then that is deleted, top of the stack is deleted. I will show the stack is empty. Even though I am trying to pop, now it will be show stack is empty. Are you clear? Are you clear? Same. Here, end user, these outputs are same in both the cases. Only the one difference, end user, what is that? Here, in using array implementation, after 10th element of insertion, it won't accept. But linked list implementation, because they are fixed the size, but linked list implementation, here we are not fixing the size. That is only the difference will appear for end user. As a programmer, we know backend what is going to happen. Are you clear? Are you clear?
Yes, sir.
Yeah.
Yes, sir.
Yeah, please. In the same way, a queue also same. Here we can implement using array. You can implement using single linked list. Here the first one using array I am showing. Using array means you have to define the size of the array. Here in queue we require 2 pointers. One is pointing to front, another pointing to rear, because here the insertion is taking place from rear and the deletion is taking place from front. That's why we need 2 pointers. Initially, the queue is empty. That's why front and rear points to -1. Now these methods as well as this menu bar is same in a main. That's why no need to change anything here. So now comes to the insertion, means adding the element. Here, when we are implementing queue using array, here when we are not inserting, the max -1. When rear is points to max -1 means the queue is full, we cannot insert. Else we can insert. Here now one more condition we have to check. That is front is pointing to -1. Here compulsory maybe the queue is empty here. If the queue is empty, maybe the rear also pointing to -1. That's why here we have to insert element from rear. But here, if we are forget about this line directly, if you are inserting from these conditions only, then the front always pointing to -1. But no. Once the queue is empty, you are trying to insert element from rear. Compulsory front also pointing to first location. That's why front equal to 0 we have to assign. Later, here we are going to insert element through the rear. If rear front is not pointing to -1, also we are going to insert element from the rear. This mechanism already I told you very clearly. Here this code meaning and everything. Now coming to the delete operation. Here, when we cannot delete the element, when the queue is empty, we cannot delete the element. Else, we can delete the element. Means simple, we are going to increment the front, plus front. But after incrementing the front, we have to check always the queue contains only single element. If the queue contains only single element, then front is moving than rear, means the indexing of front is greater than to rear, then the queue is empty again. That's why here after incrementing the front for every condition we have to check the queue is empty. The queue is contains only one element. Here, if the queue is contains only one element, then this condition is true. If this condition is true, then queue is empty. Means we are deleting that element. Queue contains only one element, even though you are deleting that element. If you are deleting that element, means the meaning is what? Front equal to, we have, the queue is empty, means we have to apply front equal to minus, rear equal to -1. So this is for deleting the element from the queue. Now display, always we have to display from front to rear. There only one case we cannot display, so that is queue is empty. Here based on the front equal to -1, we can tell queue is empty. Otherwise, we can print the element from front to rear. Are you clear this? Same lines we are discussed in the theory class. Are you clear this? Are you clear?
Yes, sir.
Yes, sir.
Now just I am executing the program. The same lines we discussed, same number of lines, same thing we discussed in the theory. That's why line by line you practice it. Now I want to display. Yes, exactly. Instantly queue is empty. I want to delete. Queue is empty. Yes or no? That's why if I wanted to add, yes, it will be accept. Enter the element. Here 23 I inserted. Yes, it is inserted from rear. Here if I want to display, it will be show 23. Again, if I wanted to add one more element, now it is going to insert through the rear only. If I want to display S 23, 34. Again it is going to. If you want to delete it, which element is going to delete? Tell me. Which element is going to delete? Hello? From this queue, which element is going to delete? If I want to apply delete. Are you there? 23.
23.
Because, yeah, front only. From front only it is going to delete. If I give 2, the 23 is deleted. If I display, the 34 is there. Even though I am going to delete, which element is going to delete? Front only. What is the front now? Tell me. What is the front
30.
now? 34. Very good. Now, here our, again I will display our queue is empty. Here this is what exactly we are discussing, same thing, same program I mentioned in our class, same thing you can follow, then you can understand. Is it clear? Here, why I am showing all these programs is these programs are there in your laboratory. That's why I am showing that execution also. Sometimes in examination they will ask write program for this implementation, stack implementation, queue implementation using array is a linked list. That is what. Are you clear? But this is very important for you. Are you clear? Are you clear?
Yes, sir.
Yes, sir.
Now fifth experiment, that is B. It is queue using single linked list. The same way, just now we discussed about using linked list. Here the linked list, the node is divided into two parts. One is for data part and one is the to store the address for next pointer. That is what I have taken. But in a queue we have two pointers, front and rear. Means insertion is one place, deletion is one place. That's why here initially the queue is empty. The front and rear points to null. If the main menu bar is same, I don't want to discuss much for menu. We know how to write. Same code you can copy and paste it. Now insertion. When you wanted to insert a new node into the queue using linked list, here first of all you have to prepare a new node and add the data. That is what a new node is created and memory is allotted dynamically and data is added. We are reading data from your main method here. Here, enter the value to be inserted. From here, from function call, now we will get this data and next the new node next is null. Here node is ready. Now if we want to insert node into the linked list, we have to check two conditions. One is if queue is empty or not. Yes or no? If the queue is empty, Here we are going to make it your new node as a front as well as rear, because it is a first and it is a last in a queue. Else means queue is not empty. Then we are going to add last node. Means you are making your new node as a rear of your queue. We are now coming to the delete operation. If you go to the delete operation, only one case we cannot delete, that is if the queue is empty. The condition is we have to check front equal to equal null, the queue is empty, we cannot delete any element. If the queue is not empty, yes, we can delete the element. Always you can delete the element from front only. It means front is moved to the next node. That node is going to delete with temporary variable. Here now display. Here you know the display always in a queue. The elements are displayed from front to rear. Only one case we cannot display when the queue is full. Yeah, that's why the condition is front equal null. The queue is full. Otherwise, we are going to display from front to rear. Instead of traversing through the front, we have taken temporary variable. We have to print all the elements until temp moves to the null. So this is the logic already which we are discussed in the class. Just now only. Just I am compiling and running my program. Please check the outputs. Yeah. Now I want to display. Now queue is empty. I want to delete. Yes, queue is empty. Then I will insert the element 23. Now display. Yes, queue is having one element, that is front as well as rear. Then again I want to insert one more element 34. Now I want to display. Yes, 23, 34. Now front is 23, rear is 34. Now I want to delete. Which element is going to delete now? Tell me. When I want to delete, which element is going to delete?
23.
Yeah, front is 23. That's what 23. Again, you display the 34. Now your 34 is made as a front. Now again, I want to delete. Now the 34 is deleted. When I want to display, the queue is empty. So this is the way we can execute and you can check and test your programs and take the clarification. So this is what the executions of these programs. Now successfully I completed first unit, and even though I completed execution and representation of 5 experiments in the laboratory. 40% of the lab syllabus is over. Already I told you 40% of the lab syllabus is depending on first unit only. Please practice. I will share these programs and after this class, please practice, and if any doubts or any clarifications are required, please don't hesitate. Please ping me or ask me in the next class. Is it clear, everyone? Is it clear?
Yes, sir.